Hello and welcome. In 2B, we will use the unit in a slightly different way and see how that help us to find the answer. Some of the things that we can do is to look at the units that we will expect for our answer. The reason for that is this. Once we know what our expected unit will be for our answer, we can then look at what other units are given, and we can try to, put them together, put the different units together to try to combine them and give the units that we are looking for. When we do that, let's remember that different units cannot be added or subtracted. So I cannot add $10 Canadian to $10 US. I cannot add $10 Canadian to 5 seconds. That wouldn't make sense. So only units with the only number with the same unit can be added or subtracted. We can, however, multiply or divide numbers with different units. I can take $10, I can multiply by 3 hours because we might be getting paid $10 per hour, and as 3 hours, I would multiply them together like that. Sometimes, instead of dividing by a number like this, 60 seconds per minute, we can think of it as 60 seconds divided by 1 minute and change that to the reciprocal, 1 minute on the top, 60 seconds on the bottom. And then we have to make sure that after we do all our calculation, we did get to the units that we are looking for. Okay, we'll put them into, we'll put these steps into use by looking at some of the questions here. In this question, we're looking for time. So we are looking for, if I look around, the only time units we get is hours. So we're trying to get to hours at the end. We are given kilometers per hour. So what we might want to do, is to put these two, combine these two numbers together to somehow get us hours at the end. Right now, we can look at this 800 kilometers per hour and think of it as 800 km on the top in the numerator, and then divided by 1 hour like that. So whenever you see the per hour, whenever you see the division sign in per, you can think of it as a division, and then it's just 1 at the bottom. Now, of course, we don't want to have hours at the denominator at the bottom, right? Because we're trying to get the hours at the end. So what we want to do is take the reciprocal of this, sort of flip it. And by flipping it, that means we have to divide. So what we'll see here is we'll divide by kilometers per hour. So instead of 800 kilometers per hour, we will be multiplying by the reciprocal. And this is good for us because now hours is in the numerator, and that's what we're trying to get to, right? We want to get to hours at the top, not in the denominator. So as I multiply them like that, you'll notice that I have kilometers in the numerator, kilometers in the denominator. I can cross them out. I can remove them. So by taking 3,400 dividing by 800, we get 4.25 hours. And we get hours because we have hours left at the top. So this is a way to look at the units to help us put the equation together. Let's look at another example. Here we have $4.50, the total price that we pay. We have a quarter of a pound, 1 divided by 4. And that's the weight of the meat that we bought. We want to find the price. We want to find the price in dollars per pound. So what we want to do is just take our dollar and divide it by the number of pounds that we have. So we take our 450 divided by a quarter pound, and we can just put this into our calculator. If we want, we can just put this into our calculator. And then we can just get to 18. And because I take dollar divided by pound, it's just dollar per pound at the end in a fraction. We don't really have to do the middle step if we don't want to. Like dollar divided by pound, it would be dollar divided by pound for our unit. Now, for example, if you instead of dividing, if you multiply, that would be a different number. So if I multiply, it would be a different number, but your unit would also be different. We will have dollars multiplied by pounds, dollar pounds as our unit. And that's incorrect, right? We want to find the price in dollar per pound. And that's how we know we made a mistake. Now, I would, in this example, we want to compare the price. We want to see which one is the better deal. And the better deal is the one with the lower price, right? The one with the lower dollar per pound or dollar per kilogram. And this is what we could ask you on the test, on your assignment or on your exam. We can ask you to compare the price of two different items. So you can pause and you can give it a try. And here we'll show you how it's done. So first, if I look at the grocery store, we pay $4 for 2 kilograms. So we will just divide to find the price. Once I divide, that will give me $2 per kilogram. Now, in order to compare them, we want to change the kilogram to pound or pound to kilogram. Since we are already working with this number, let's change the 1 kilogram to pound. Because kilogram is in the denominator in this case, let's put the kilogram in the numerator in our conversion factor. Then we will put the 2.2 pounds in the denominator. And this way, we can then remove the kilometer because I have one on top, one on the bottom of my fraction. And then we could do our calculation. We take 2, we divide it by 2.2, and we'll get to the answer of 0.91. $0.91 per pound. Now at the farmer's market, it's $1 per pound. So $0.91 per pound is cheaper, right? It's a smaller number. We will also be using units for energy and power to do some of our questions. Energy, the energy that we usually use in science is joules. And power, the unit for power is watt. And that means in 1 second, we will use up the energy of 1 joule or provide the energy of 1 joule. Now, to help you quickly understand the relationship between those two, let's think about 500 calories per hour. Let's say we're burning 500 calories per hour when we bike. And that's actually quite a lot. Usually it's not that much. 500 calories would be going completely all out for 1 hour. And it turns out 1 calorie is 4,184 joules. They're just different units. It's like Canadian dollars and like euros, 2 different units. But they represent the same idea, right? How much things cost or how much money there is. In this case, that represents how much energy. So what we want to do is first, let's change this. Let's change the 500 calories per hour into joules. And because I start with 500 calories per hour, I want to put joules on the top and calories on the bottom. This way, this allows us to remove the calories. Now, eventually, we want to get to watts because we want to compare the answer to a 100-watt light bulb. So eventually, we want to get to joules. We want to get to joules per second. That's what we want to get to. So you notice here we have joules now. Hey, that's great. But we want to change the hour to seconds. So we will cross the hours out. So we'll have to add another conversion factor, put 1 hour on the top, and somehow change that to seconds. 1 hour is 60 minutes, and 1 minute is 60 seconds over here. And you'll notice almost all the units are gone. We only have joules and seconds left. And that's what we want, that's watts. If I have a whole bunch of numbers multiplying each other, just remember, only multiply the numbers on the top and then divide it by the numbers in the denominator. Here we'll take 500 times 4184, and then we divide it by 60, and then divide it by 60 again. We don't have to do anything with the 1. This will give us 581 watts. So if I'm biking really hard, that's enough energy, that's enough power that I'm putting out to make the light bulb glow. Now, of course, here we have multiple steps. On your assignment and on your exam, we're only going to give you conversions that either involve 1 step or 2 steps at the most. Okay, we wouldn't give you, like in this case, 3 steps. Now, the bills that we get, for electricity, the amount is calculated in kilowatts per hour. And just to quickly show you, not kilowatt per hour, kilowatt hour. Kilowatt hour is kilowatt times hour, and kilo means 1,000. So that means 1,000 joules per second. If I multiply them together, that means it's 3.6 million joules. So it's another unit of energy. So joules is a unit of energy. Kilowatt hours is a unit of energy, and we see that on our BC Hydro bills. And of course, calorie from the food that we eat, that's also another measurement of energy. So you don't have to once again, you don't have to remember any of these numbers. We'll give it to you if I need you to convert them on your assignment or on your exam. But here, I just want to let you know that these are different units of energy that we might encounter in our daily lives. We will, however, on your assignment and on your exam, give you something like this, where we ask you to calculate the amount of money we pay for electricity. So here we have two different refrigerators. One that uses more electricity, more energy, and the other one that uses less electricity. And we want to find out how much money do we save. You'll notice that the difference is 254 kilowatt hour. And every kilowatt hour is 0.095, so 9.5 cents. How do I combine them to find the money that we save? Now remember, to find the money that we are saving, we need to find dollars. So we want dollars on the top. So eventually, we'll have something like this. We'll take our $0.095. We'll try to leave it like this. We'll put it in the numerator. And of course, per means divide, right? Divided by 1 kilowatt hour. Since I have kilowatt hours on the in the denominator, I will need kilowatt hours in the numerator so that I can remove them. Then I would just keep my kilowatt hour per year like this. Have years in the bottom, 254 on top. Then I just multiply, right? And you might not want to write everything out in such a complicated way. You can just think to yourself, we say 254 kilowatt hour, and each of these kilowatt hours is 0.095. Oh yeah, well, of course we have to multiply them, right? I have 254, and each one costs that much, so I multiply. Multiplying that gives us $24, so we save $24 per year. Now, if you use your fridge for 10 years, you're going to save around $24 times 10, right? If you use your fridge for 10 years. So that's a big saving, $240 if you use your refrigerator for 10 years. This is why when you look at the price of the fridge that you're going to get, it's good to get the one with the lower energy consumption, because you do save on the electricity bill, and it's quite a lot, right? It would be a couple $100 and maybe more if you use your fridge for longer. A couple of things that we will also do, a couple of types of units that we'll use. One is the density over here, and density tells us how crowded we are. So a room full of students will have a high density. But a room with very few students inside, that would be a low density. To find density, we would take the number of items, students, or in this case, water, how heavy things are, and we divide it by the space. We divide it by the space, like the size of the room. Or in the density of water, we might divide it by the size of your cup. We have population density, how many people live inside a certain area. We can have information density, like how much memories we pack into our computer or our hard drive, that type of things. Let's look at an example. Once again, when we look at the example, think about the units that we are trying to find. In this case, we are trying to find population density. And when we try to find density, it's always dividing by the space. And this is our space over here. So we want to divide it by that. So we want to take the people and we want to divide it by this space. So we take the people that we have living in Greater Vancouver, and we divide it by the 490 square kilometers that we have. It turns out it's 5,300 people per square kilometer. And in case you don't know what a square kilometer block is, we can sort of look around, we can change it a little bit to help you sort of see the amount of space we have. So of course, normally like a typical assignment or exam question would be something like this, asking you to calculate the density. But let's do something more fun, right? So this extra part is something that's more fun. We can take the kilometer, we can take the density, and we can flip it around because we want to find out how much space do we have per person. So we'll flip them around, and we'll have number of people in the denominator and the amount of space on top. And just a quick reminder, to get to square kilometer, we take kilometer and meter, and we try to square both sides. In this case, if I put them in a fraction, I just have to square them like that. So I find that there are 1 million square meters and 1 square kilometer. This tells us it's about 190 square meter of space. So a typical high school classroom or a small classroom that sits 30 students, that's sort of roughly the size. So it's Vancouver is a pretty good place, right? If we spread everybody out, everybody has like a classroom, a size of the amount of space that's equivalent to the size of a classroom all by yourself. Concentration is something similar as well. We take, but instead of dividing by space, we might be dividing by the total number of molecules in this case, if we are talking about pollutant. If we're talking about medicine, we might be dividing by the person's weight, body weight. And of course, for blood alcohol content, you notice that it's divided by how much blood we have, how much alcohol inside like a certain amount of blood. And the blood alcohol content is what the police will test you when they are checking for drunk drivers.